All right, so let's look at this problem. We've talked about it a little bit already, but the first thing in terms of strategy, we probably are going to want to find the reactions at D and E to give us some things to work at there. And also we're going to look for zero force members. So doing that first, the case 1 condition we talked about for zero force members, I see 1 here at joint A. So since we have 2 members connected and no external load, that means that this element and this element are 0. There are no other case 2s. It looks like you might create a case 1 here, now that this one's gone, but there's an external load at E, and similarly there's an external load at C. And then there's no case 2s, no 3 members connected, 2 collinear. So we got 2 pretty quickly. So that's nice. Let's go ahead and finish the problem. I'll have EY and EX at my pin and DY at the roller. So let's find those reactions. I'll start by summing moments at the pin, E, equals 0. So, what kind of moment does D create about E? Positive or negative? Positive. So I've got dy, and what's its moment arm? 20 feet. And then the load up here, which happens to be the only load on this problem, 100 kips, creates what kind of moment about E? Negative. So I have 100 kips, and its moment arm is 30 feet. So it looks like dy is something weird. 3,000 divided by 20, which is 300 divided by 2. 300 divided by 2? 150. And that'll be kips. And it's positive. So now we can... is there a question? No? So we can sum forces in the y direction. So I've got EY up, DY up, nothing else. So that means that EY should be equal to negative DY, which is negative 150. That kind of makes sense too. If you sit here at D, kind of think about it, if this force is trying to rotate it clockwise, well, then this force better balance it counterclockwise, which in that case would be negative. And then finally, we'll sum forces in the x direction. As you can see, there's the reaction EX to the right, and then our applied force of 100 kips also to the right. So it looks like EX is opposite, or negative 100. So it's actually pointing to the left. So we have our reactions. So of the remaining joints that we have, B, C, D, and E, where's a good place to start? E. E would be a good place, just 2 unknowns. And what's good here is that DE is just horizontal, and BD is just vertical. That's a good one. Where else should we go? Probably C would be easy. Again, only one has an X component. We should be able to get that pretty good. And then we'll just have to decide which way we want to go with the other 2. But yeah, let's start with joint E. That seems to be the easiest one to do. So we'll start with joint E. So let's see what forces are on it. So EY we found was down, equal to 150 pounds. And EX was to the left, also 100 pounds, right? Kips, sorry. And then our tension forces are unknown DE, horizontal, and unknown BE, vertical. It's going to take us longer to write it down than it'll be to solve these, but let's do it anyway. So no particular order here. I'll just sum forces in the Y direction first. So I have the force in BE acting up, and then minus 150 pounds acting down. So it looks like the force in BE is 150 pounds. Kips. Kips. Yeah, that's my K. I have a new K. It looks like L and a B, but it's really a K. Oh, I did it here too, didn't I? Well, at least I was following my free body diagram, which was incorrect, but still. Sorry about that. So, BE is in tension. So now we can sum forces in the X direction. Let's see if I can get my units right this time. So I've got the force in DE to the right, and then to the left 100 kips. So the force in DE is 100 kips. So both those forces are tension. So I'll go ahead and put a little tick mark through those. I got those two. So I just have 3 left. Now technically I could go to B, C, or D. They all qualify now. Because even at B there's only 2 unknowns. Now that's not a good place to go, because your unknowns BC and BD both have X and Y components. That's 2 equations and 2 unknowns solved simultaneously. Probably not a good spot. C, only one unknown has an X component. That would work. And also over here at D would work. Now I'm going to choose C because I can solve these forces at C without including any of the previous calculations. So I get an independent check on that. If I go to D, I'm going to have to include both dy, which I computed, and the force in DE, which I computed. So I think C is a better place to go. So at C I have my 100 kip force, and I'm going to assume tension in CD and tension in BC. And I'm also going to look at the orientation of this. It looks like for BC I drop 15 feet and go over 20. If you divide those all by 5, you get a 3, 4, 5 triangle. So it'll be 3 vertical, 4 horizontal, and then of course the hypotenuse would be 5. So that's going to help me with my calculations. So since BC is the only one with an X component, that's where I'll start. I'll assume right is positive. So when I sum forces in the X direction, I have minus 4/5 of BC. That's the horizontal component acting to the left. And then the 100 kip force acting to the right. So it looks like the force in BC is positive 125. Is that right? 500 divided by 4?
Yep.
That kind of makes sense. With this setup, as you pull here at C, you'd expect the joint C to move to the right. So more than likely BC would elongate, get tension. And now that I have that, I can sum forces in the Y direction. And should be able to find CD. So when I do that, I have now the vertical component of BC. So that would be 3/5 of the force in BC. That's acting down. Sorry, I lost my minus sign. and then minus the force in CD. So I should be able to find the force in CD. What's that, 75? And it should be negative. You guys get that? And that's kips. So now if my accounting is correct, we've got this one, we've got this one. So there's only one left. The force in BC. I think still B is not going to be a good place to go with all those elements. Probably the best place to go would be D. And the other great thing about it is at D, I can probably find this in one equation, either some forces X or Y. I don't know which would be easier. Probably summing forces in the X direction. So let's finish this off by going to the joint at D. I'll draw my free body diagram. A lot of stuff to add here. So we got dy, which was up 150 kips. I've got the force in CD, the force in DE, and then the one I'm looking for, the force in BD. And it also has a similar orientation. It looks like 4 in the horizontal and 3 in the vertical. So another 3, 4, 5 triangle. By the way, the author loves those 3, 4, 5 triangles. So look for them. And let's just do a little bookkeeping here. I do have DE and I do have CD. So whichever one you want. So all of those were computed. So if I sum forces in the X direction, I only use one computed value instead of 2. So it shouldn't matter, but I'm going to do it. Plus one less force to account for. So I'm going to sum forces in the X direction. And when I do that, I have minus the force in DE and minus the horizontal force, which is 4/5 of my last unknown BC. So I should find the force in BC to be, what did I get for DE? 100? It's 125 again, except I think it's minus. You guys get that?
Yep.
And that's kips. So I think that's it. Now remember, in my process, I always assume positive forces. So when I get my signs, positive is tension, negative is compression. So any questions about that one? Okay.